Recording stopped.
Okay. So hope you all remember what we have learned up to now. So we just completed theory on JVM. So observe it has two chapters, JVM and JVM architecture. So what is JVM? JVM is nothing but a virtual machine. So it is a platform responsible for executing Java bytecode. Why JVM? For providing platform independence. Next, what is a virtual machine? It is a software implementation of a computer. It is responsible for providing runtime environment to install and run one operating system inside another operating system. Generally, people say virtual machine is an abstract computer. Abstract means what? Hidden. Hiding concept is called what? Abstraction. From computer world, hiding is nothing but abstraction. So abstract, a virtual machine is a software implementation of an abstract computer. So it divide the computer into partition memory areas for running programs parallelly. So what is the advantage of a virtual machine? It divide our computer into partitioned memory areas. So tell me, we have drive. Drive is nothing but what? Partitioned memory, DCE. We are divided memory into partition memory. We partition. So equal memory you provide or different sizes memory you provide, that is up to you. So virtual machine also what is doing? It is creates computer inside computer virtually, means it is abstracting the computer by dividing the memory into equal partition memory. Okay. The next, whenever you want to run one OS inside another OS, then we should use virtual machine. Or if you want to execute a program in a platform independent way, we should use virtual machine. So we have two types of virtual machine, system virtual machine and process virtual machine. System virtual machine provide runtime environment to install and run one OS, whereas process virtual machine will provide runtime environment to execute a program in a platform independent way, right? So finally, what is a JVM? JVM is a process-based virtual machine. It is meant for providing platform independency. Okay, types of JVMs, we found two types of JVMs, and also we got clarity on what is hotspot. Okay, how this hotspot is implemented by using just-in-time compiler. So just-in-time compiler will not run our program, interpreter only will run our program. Just-in-time compiler helping the interpreter to execute program fast. So how just-in compiler can help interpreter to run program fast? By generating machine language only once and sharing that machine language every time to interpreter to execute. Okay, right. How just-in-time compiler knows which is a hotspot? For that purpose background, we have something called what? Hotspot profiler. Okay, then difference between client JVM, server JVM, we have also understood. So these are the topics we have completed in up to last class, right? Now today we'll try to understand few more points about JVM only. So JVM architecture, it is a two topics, JVM and JVM architecture. So first you are trying to understand JVM and then we'll go for architecture. Under JVM we have two more points are there, try to observe. How can I start JVM? I want to run Java program. For that I should start JVM now. How can I start JVM? Come on, answer. I ask question. How can I start JVM? By using Java command. Where? From command prompt. Okay. How can I start JVM? By using Java command. Okay. If I start JVM, what happened background? Tell me. When you run Java example, what happened background? In a command prompt software, we run Java example. So first JVM will be started. Up to now, we have not considered JVM starting. Okay. Now we are starting JVM now. Now onwards, we have to consider. Up to now, we are understanding only one thing. What is that? Java. Just executing this example class and we are getting output. But now our target is different. When you run Java example, first Java command will create JVM. JVM is assume like one rectangle dabba, circle, whatever you want, you can consider. Right. Inside JVM is a memory. It is a process. Process will start by occupying some memory from RAM. Okay. Then JVM software, you are asking JVM to execute class example. Then JVM searching for this class example inside where? JVM memory. Inside JVM memory, is the class example is available? No. Where the class example bytecode available in hard disk. Then JVM software will go to hard disk, searching for the class example.java, example.class. Example.class, searching for example.class, found. Then it is reading the bytecode available inside this .class file, loading and storing inside JVM memory. So what JVM is doing? So when you run Java command, JVM is started and it is reading the bytecode available in the .class file and storing inside JVM memory, converts that bytecode into current operating system machine language executed and shows output. Okay, so this is the basic idea. First you need to understand. Okay, so just accept and remember. I'll go more elaborated discussion in the next slides. So now, how to start JVM? By using the command Java. Okay, can I start multiple JVMs at a time in the system? I have opened command prompt, then I type Java example. Now, while this JVM is running, while the Java program running, using same command prompt window, can I run one more JVM? No, because command prompt is a single task application. Okay, it will take only one program at a time. Only one program can execute. Can I open one more command prompt? In that one more command prompt, can I run Java command? Yes. All are catching my point? So try to answer now. If you wanted to run multiple JVMs, then what should I do? I should open multiple JVM, multiple command prompts. First command prompt Java example, second command prompt Java sample, third command prompt Java A. Like that, we can run multiple Java programs. Are you catching my point? Now my question: to run multiple JVMs, different versions of JVM, do I require virtual machine software? Not required. Okay, some people are feeling that virtual machine I should install, like a what, a system virtual machine I should install. Not required. Okay, simply you have to open multiple command prompts. In first command prompt, you run with Java command of one version, 8 version. Second command prompt, Java version of another version like 17 version. Your wish, any version or same version you can run by setting the path. Now, then what is the need of executing multiple programs at a time? You know, when you are developing client server applications, okay, like web applications if you develop, or distributed applications if you develop, client server based applications if you develop, server as a one program running. Okay, one program as a server running. Now to send a request to this program to execute some operation background, we need what? A client program. For example, you take Amazon. Amazon software is available in somewhere in the one server computer. Now the project is executed by sending your request, right? By clicking some hyperlink or by clicking some button, you are sending request. To send the request, we need one more program called browser HTML program. That browser HTML program is nothing but what? Client program. And the server side running Amazon software is nothing but server program. All are catching my point? So this client server architecture, if you want to develop using Java, then one program should run as a server continuously. Then another program should run to as a client application, should send the request. So finally, you please tell me how many command prompts are required now? 2. One command prompt, Java software is running, JVM is running as a server, and another command prompt to run what? Client. So this is the diagram for that. I have one command prompt with a sample program as a server program, distributed application, RMI server or web application servlet. Okay, so it is running here. Then I want to send the request. So if you want to send request to the servlet, the program should be applet. If you want to send request to RMI server, the program should be RMI client. So in next coming courses, you are going to learn this applet, servlet, and RMI client, RMI server. In advanced Java, next in Spring, you are going to learn. So if you want to develop web applications or distributed applications, the architecture is client server architecture. For client server architecture to develop, how many JVM should run at a time? 2 JVMs. So in core Java, do we need multiple JVMs at a time to run? Not required. Okay, in core Java, we have networking chapter. Okay, in a networking chapter, if you want to develop networking applications, there again we required what? Server and client. So that time again we required multiple JVMs to execute. So we discussed about how to start a JVM. We can start JVM by using Java command, using one command prompt. So if I require to start multiple JVMs at a time as a client server architecture application, then we should use 2 command prompts. Use from 2 command prompts, we can run multiple JVMs. Everyone understand? Then now try to answer now. Whenever we run Java command, what is happening background? Okay, so complete story I want you to tell me. From the command prompt, I run a Java command to execute the class called what? Example. So what is happening completely? Now this is our JVM, sorry, this is our OS, okay? This is our operating system OS. Now tell me, operating system is controlling hard disk, na? Okay, it contains all the different data. Hard disk, not disk. Hard disk. Inside a hard disk, we have our example.java file, example.java file, and we have example.class. Example.java file, example.class. Now I want to execute the class water example. Then first Java command creates JVM as a process. You can take it as a circle, or you can take it as a what do you call a square box. Don't worry about it. Okay. Now according to diagram, I'm changing it. It's like a water. Okay, water changing its shape, na? Like that. JVM is started as a process by occupying some memory from RAM, right? Then now JVM is ready. Now JVM is responsible for executing the class called what? Example. Then JVM first looking into hard disk and what the steps JVM is having internally. So Java program is not directly executed. Java program execution has implicitly some steps. So what the steps are there? I'm trying to understand here. Observe example, first JVM is performing first task is what? First operation is what? Loading. What it is doing? Loading. So first it is loading the class example into JVM. After loading, tell me, Java program is loaded within the same system from the network also. If you take web applications, now the programs are client-side execution applications. Applets, if you take, programs are loading from network also. Okay, from server computer, program is traveling via network wires and then coming to our client computer and loading into our local JVM. Then while it is traveling from client server system to client system, there may be a chance some people may attack our code. Some may be injected some malicious code or virus that maybe there is a chance. Na? So that's why compile. What JVM will do after loading the bytecode, immediately it will not execute. So it is background verifying the loaded bytecode is valid or not. What it is doing? It is verifying loaded bytecode is valid or not. So it is performing an operation called what? Verifying. So it will first load the code. After loading the code, it is verifying whether the loaded program is valid or not. If it found yes, it is a valid code, then it will allow us to execute. So first step is what, buddy? Loading. After loading, next step is what? Verifying. After verifying, now the program execution started. Tell me, is your program directly executed or converted and executed? Converted and executed. This conversion, complete code at a time converting, a line by line converting. Line by line. The line by line conversion is called interpretation. So what operation using third operation? Interpreting. So loading, verifying, and then what? Interpreting. Then from the interpretation, now you are getting what? Machine language code of current operating system. Na? Interpreting, third step. After interpreting, it generates what? Machine language. Okay, generate machine language. And now that machine language, with the help of current operating system, it is executed, and finally we are getting output on console. So this is the complete flow of execution of our program. So a program execution comes under how many stages? 3 stages. Okay, how many steps? 3 steps. First step, loading. Second step, verifying. Third step, interpreting. Okay. Now the question, what is happening in the loading phase? In a loading phase, JVM software searching for the given class .class file in the hard disk. If found, reading the internal available bytecode and storing inside JVM memory. Next, in the verification phase, what is happening? The loaded bytecode is valid or not. It is checking. Okay, the loaded bytecode is valid or not checking. Okay, valid or not, so many points it will verify. Okay, So many points will verify. In the coming classes, I will explain you what are the different points it is verifying. At this stage, I don't want to talk much, okay? You cannot understand, you cannot digest. So verification phase, simply one word, remember, JVM verifies each and every byte code available in the .class file is according to the JVM format or not checking, okay? If it is according to JVM format, then it is going to next level interpreting. In the interpretation phase, what is happening? Interpreter software converts each byte code into machine language of current operating system. With the help of underlying operating system, it executes the machine language and generates output and display. All people understand? So whenever I say Java example, from up to this chapter, before this chapter, you all people are having only one thought. Java example means go to example class, go to main method, execute logic. So this is the flow you have. From now onwards, what is the flow you should have? Java example means, okay, JVM is prepared as a process by occupying some memory from RAM. Step number 1. Step number 2, it is loading, it is searching for the .class file and loading bytecode inside JVM memory. Third step, verifying the loaded bytecode valid or not. Fourth step, it is interpreting, converting. And fifth step, it is executing. So in a fifth step, it is searching for what? Main method. Until that fifth step, you should not look for the main method. So this thought should register in your mind. So Java program execution has totally 3 steps. Step number 1, loading. Step number 2, verifying. Step number 3, interpreting. From interpretation, the flow will come. Okay. Now my question, who will load bytecode into JVM? JVM. Who will verify loaded bytecode? JVM. Who will execute loaded bytecode? JVM. Who will teach core Java? Naresh sir. Who will teach advanced Java? Naresh sir. Who will teach Oracle? Naresh sir. Because institute name is Naresh, na? Huh? Because JVM is the software name is JVM. That's why JVM is doing all the work. No. Naresh, institute name Naresh means what? It is managed by Naresh sir or some other person there in the office, right? Same point here. JVM will not load the class. JVM will not verify. JVM will not interpret. JVM just manage. Are catching my point? So JVM just manage. JVM software has several components to perform these operations. Tell me, I am teaching. So you are calling me as what? Teacher. You are listening. You are called what? Listener. He is walking. That's why he's called what? Walker. Okay, no, right? So now what operation you are performing, based on that ER is coming. Are you catching my point? Same way, I need one class, I need one program. See, in Java, everything is what? Class only. So inside JVM software, there is a one predefined class that perform what operation? Class loading operation. Can you tell me what the name of that class? Teacher, teacher. Loader, loader. What it is loading? Class. So what is the name of this code? Class loader. Remember in first chapter, hello world application, after I develop on some programs, name printing. What is the name of the class we taken? Name printer. Right? A name printer, right? Same way. Now it is loading. So class name should be loader. What it is loading? Class. That's why its name is what? Class loader. So tell me, inside JVM software, we have one special program or special class for performing which operation? Class loading operation. So class loader is responsible for loading a class. So once a JVM setup is completed, JVM software instructing class loader, right? Go and search for example.class in the current directory. Find it, read the bytecode, load inside JVM memory, nothing but store inside JVM memory. Okay, class loader complete its job. Next, who is coming to picture? Verifying. So tell me, who will be there inside JVM to verify the loaded bytecode? Come on, verifier. What it is verifying? Bytecode. So the name of this program is what? Bytecode verifier. Bytecode verifier. So bytecode verifier is responsible for verifying the loaded bytecode valid or not. If the loaded bytecode is valid, then it will allow for next step what? Interpretation and further execution. Then tell me, who will interpret our loaded bytecode? Interpreter. So now interpreter, come on, interpreter alone working? Conversion of machine bytecode to machine language? No, it is taking help of another program. Who is that? JIT compiler. Okay, it is taking help of JIT compiler. you know, when you are calling, see, you are executing and you are accessing the methods of another class also, na, right? Variables and methods of another class also you are accessing. As long as you are accessing variables and methods of your own class, no objection. When you are trying to access the variables and methods of another class, that class may give or not give permission, na? So permission there are not to verify. We have one special program called security manager. Security manager. So totally, how many programs are working together to execute our class? 3 programs. What are the 3 programs? Interpreter, JIT compiler, and next security manager. Right. So these 3 programs are working together to run our program. So hope you are comfortable with this. So what happened when I run Java command? What happened when I run Java command? Java program is executed. Java program is executed with how many steps? 3 steps. Okay. Now first step, class loading. Second step, verifying. Third step, interpreting. Who will load the class? Class loader. Who will verify? Bytecode verifier. Who will interpret? The interpreter, JIT compiler, security manager. Okay. Now I wanted to prove this process is there inside JVM. Okay. How can I prove it? How can I prove it? I can take you into the JVM, right? I can make you travel like water through all this process. That is the one way. Is it possible? Not possible. Second way is what? Get errors. Okay, now if I get errors, then okay, JVM is telling that sorry, class loader unable to find. Sorry, bytecode verifier found there are some mistakes. Sorry, interpreter is found some problems, throwing error. So I want to talk JVM with those programs to us. Okay, na? Shall I prove that? Do you remember in a data type chapter I proved that 10 is of type int, 10.5 is of type double by assigning to different type of values and different type of variables. We got error, right? Same way I will also ask JVM, throw me errors. Let me try to develop a small program. Notepad edit plus Notepad jamana gone, na? Sir, up to now, whatever the chapters I covered, what are the points I explained? Did you remember? All points, remember? Really? After this chapter completed, I'll give one program. Can you develop? I will design a one program which cover all topics, whatever we have discussed. Really? We will see. But I will give you suddenly, Ray. I will not tell you before one day. If I tell you one day before, next day, I will only be there in the class, right? Okay, this is a small program I am taking. Okay, I wanted to open command prompt. Open command prompt. JVM architecture. You can also done from the edit plus, but still I want to use command prompt. Clear screen. Java C example.java. Any compile time error? Yeah, Manikumar, I wish to remove you from the class. Manikumar. Okay. I'm removing you from the class. When I start Eclipse, I will make you join. You can join. Okay. Removing you. Ready now? 1, 2. Huh? Don't show your talent in front of me, okay? Come to the story. So now I'm running the class. Listen. When I type Java C example.java, what happened here? Compiler software verifying, are there any syntax mistakes? No syntax mistakes. It's generated .class file. Now when I run Java example, then what happened now? JVM. Now you should visualize here background JVM Dabba created. Now JVM requesting class loader to search for example.class. Then class loader going to hard disk in the current directory. It is found example.class. Then example.class file is reading the bytecode from the example.class file loaded. After loading, bytecode verifier verify the bytecode is valid. And then next it is it is giving next step to interpreter converting the bytecode to machine language and executed. Finally we get output. That means no problem in loading, no problem in verifying, no problem in translating, no problem in execution. So we got output. Is it clear to all? Now I wanted to create problems. Ready? Java A. If I write Java A, what happened? The system doesn't have old versions Java. I cannot show you now. The system, I don't have old version JDK softwares. I want JDK 6 version to show you errors. Latest version, it is not giving complete details. So tomorrow I'll bring those softwares, but current for the time being, you just try to understand. When I run Java A, class loader searching for what? A.class. Is A.class file available here? No. Then it is throwing exception. Could not find or load main class A caused by java.lang.class not found exception. Tell me, who is throwing this exception? JVM class loader? Class loader. That information I cannot show you because latest version Java not showing the complete exception information. Up to Java 6 version, there is a complete detailed information, but now there is no information here. Okay, tomorrow I will bring all old version JDK software install here and I'll show you. Okay, next point, try to observe. I have example.class, right click this example.class, open by using Notepad or edit plus your wish. This is the bytecode. Can you understand? Notepad also not understood. Edit plus also not understood. That's why it is showing all dabbas. Okay. Somewhere in the middle, I am writing. Okay. My name I have added. Virus added. Virus. Okay. JVM Harikrishna is a virus. Save re. Save Harikrishna, save. After saving, go to command prompt, compiler. Will you compile it again? If you compile it again, original .class file will come. We want to execute bytecode with problem or without problem? With problem. So we should only execute Java example. When I type Java example, class loader searching for example.class file. Is it available or not? Yes. Then it will start reading the bytecode and store the bytecode inside JVM. After loading, who will come into picture? Bytecode verifier. Bytecode verifier found. Bytecode verifier will read each and every line there in the bytecode and somewhere in the middle found what is this Harikrishna. Okay, is a bytecode verifier understood or not understood? Is it in the format of bytecode? No. Then now bytecode verifier will throw exception. What the exception? Linkage error occurred while loading main class example java.lang.class format error invalid superclass index something. Okay na? Right. So tell me, bytecode verifier verifying the loaded bytecode valid or not? Right. And now I am removing this Harikrishna, save it, go back and execute. Program executed successfully because the malicious code is we removed. Okay, somewhere here I am writing Naresh IT. Okay, NIT, save. Then come back here. Again execute. One more time, again you will get what? Exception. What the exception? Linkage error. Okay, the bytecode is linking to JVM software to execute. It is unable to link. So that's why we are getting error, linkage error. Why the linking problem we got? Because of class format is not properly there. Class format error, unknown constant tag, something error coming. Okay, I'm removing NIT. So now we have added some code, we got problem. What I will do? I will remove one character. Okay, now I'm removing one character, save it, go to command prompt, clear screen. Now let me run again. Then what happened? Let us observe. Now again we got error. What is that? Linkage error. It is unable to link this bytecode to the JVM. So now it is throwing error. What the error? Again class format. This time what is missing? Incompatible magic value. So tell me, Java has a background some magic. Okay, so some magic number is there to identify it is as a dot class file. That magic number missing. So whatever you do, okay, slowly remove all the cat data. Make the dot class file empty, save it, go to command prompt, empty class you try to run. Then JVM, bytecode verifier will throw error, linkage error, what? Class format, truncated class file. I hope you know truncate means in a Oracle truncate means remove permanently, na? Right. So the file is empty, Babu. What I can execute, get out or tumri file is throwing error. So tell me, loading, class loader throwing error if the class is not found. Next, bytecode verifier is throwing class linkage error, and what? Internally class format error if the bytecode is not valid. Then place it back, save. Now Control Z, place it back, save, and then run, executed successfully. So I have shown you class loader is participating. Second step I have shown you bytecode verifier participated, and third interpreter also I want to show you. Look at there. I'm opening this file once again using open the source code. Here I am writing correct message here. Here I am writing correct message. What is the main start? And next I am writing another message, main end. Between I am writing one statement here, 10/2. Tell me, any problem in execution? No. Program compiled successfully, no syntax mistakes. And then executed. No loading problem, no verification problem, no translation problem, logic also no mistakes. Finally we got output, main start, 10/2, 5, main end. Now I want to create a problem. In place of 2, I'm writing 0. You cannot divide a integer by integer 0. You cannot divide integer by integer 0. In mathematics, it is infinity, but in Java, it is not infinity. You will get exception. Java C example.java, Java example. Look at that. We are getting what exception? Java.langler arithmetic exception. Who has thrown this error? This exception, we throwing this exception. Class loader? No. Bytecode verifier? No. Who is throwing? Interpreter. Interpreter, while running your code, it found some problem, so it is throwing exception. So finally tell me, when program execution, we will get exceptions in all 3 stages. In loading stage, we will get class not found exception. In bytecode verification phase, we will get class format error, and execution time interpreter also can throw different exceptions based on the mistakes you are doing. Maybe arithmetic exception, maybe number format exception, maybe class cast exception, maybe array index out of bounds exception, null pointer exception. You have experienced these exceptions in reading runtime value chapter, right? So input mismatch exception, based on the mistakes you are doing, you may get several exceptions. So you have to remember all these flow, then only you can solve questions correctly. You can find correct output in the coming chapters. So repeat once again, what happened when I run Java example? When I run Java example, first step, JVM is created as a process by occupying some memory from RAM. The next, JVM requests the class loader to load the class from the hard disk into JVM. Then class loader searching for example.class file in the hard disk, then found, then reading the bytecode and storing inside JVM memory. The next, after storing, class loader initiate bytecode verifier to verify the loaded bytecode, very valid or not. If it found loaded bytecode valid, then it initiate interpreter. Then interpreter, with the help of JIT compiler, it will execute our bytecode by converting into current operating system machine language and will generate output. In the process of loading, verifying, and interpreting, we may get what? Several exceptions. If the class is not available, it will throw class loader will throw class not found exception or no class def found error. Okay, next, in the verification phase, it found some bytecode mistake, invalid bytecode is there. Then it will throw exception. What exception it will throw? Linkage error or class format error. Sometimes linkage error, sometimes class format error you will get. Next, if there is no verification problem, and further if you have what do you call execute logic mistakes, if you develop any logic mistake, interpreter will throw different types of exception based on the mistake you committed. So hope all you people understood. Will you remember the 3 phases? Then tell me, totally Java program compilation, Java program compilation, execution, Java program development, compilation, execution has comes under how many phases? 5 phases. Okay, first develop. Okay, second compile, third execute. Under execution, how many phases? 3 phases: loading, linking, verify. Loading, verify, and what? Interpret. Okay, now look at here. Develop, compile, and execute a Java program has totally 5 phases. Editing phase. In editing phase, what it is doing? We are typing Java program save by using .java file in hard disk. And next, in the compilation phase, by using Java C command, we compile the program .class file generated, and it is saved in the current same directory. Then in execution phase, when I run Java command, JVM phases are started. JVM has 3 phases. First one, loading. It reads the .class file bytecode from the hard disk and stored inside JVM memory. There is one special memory called what? Method area. It is loading into method area. Now, in method area, it is trying to store. If it not found, it throw exception. Class not found exception or no class def found error. Then next, in verification phase, it verify the bytecode valid or not. If not, it will throw class format error. In interpretation phase, it read the bytecode from method area and start running the bytecode by converting into machine language and generate output. If you create any mistakes, then it will throw exception. Samajh mein aaya? All people understood? Today comfortable compared to yesterday? Yesterday some new points are there. I told you yesterday you don't understand, but if you read today, you will understand. Today notes, if you read tomorrow, more easily understand. If you read these 3 days notes, from Friday, Saturday onwards, you will enjoy, you will get peaks. Up to now, last 2 months, maybe you are feeling that I should go to class, Forcefully, you are pulling your body to the class. From Monday onwards, from Saturday onwards, by 8:30 only your body wake up automatically. It will push you, right? Go to the class. Mind is started generating some, motivation to you. Go and work with the class. And without your knowledge, you will come to the class. Even though you are sleeping, your legs will take you to the class and make you sit here. Without your knowledge, your mouth will start talking. Ready? It's a challenge. Okay. People who study this JVM architecture, yesterday notes, today notes, tomorrow notes. These 3 notes, people who study, Java will become damn easy to you. Everything you will get visualization. Up to now, you don't have visualization, but now onwards you will have full visualization. Okay. If somebody give free ticket to watch Japanese movie, will you go? No, time waste, right? Because you are not understanding, not getting visualization. If somebody give you free ticket to your favorite hero movie, first in the race will be there, right? So your Java is become now, up to now Java is a Japanese movie. From tomorrow onward, Java will become what? Your favorite hero movie. Ready? Shall I move to the next story? Up to now we completed JVM. Now is the time we have to go for JVM architecture. 1 minute. Somebody has sent big message. Let me read. I want to create JVM in future or would like to create something similar to Linux. Okay. Enjoy above. Okay. Okay, now try to answer. I'm running Java command. Okay, Java example. Listen. Now I want to launch JVM architecture. First, you tell me what the meaning of architecture. What is the meaning of architecture? In my academics, my lecturer used to talk architecture, architecture. He is making it heavyweight. Architecture, okay, very important. Okay, because of that heavy sound, we all get fear. Wamu, architecture and very tough. And even our college lecturers also make us very scared about the topic. Data structures, okay? Data structures are the most easiest topic in the world. You know, college lecturers make it very tough because it's tough to them and make the same topics tough to us. Data structures is the most easiest story, easiest concept. You know, when I start collections, you realize, you know, now I am teaching collections. Now people are complaining me that I am not teaching collections depth. Okay. Yesterday, one student complained, sir, like you teach variables, like you teach methods, like you teach, you know, class and object, that depth you are not teaching, sir, collections. I surprised. Okay, why you are feeling that I'm not teaching depth? And you used to say that, you know, and our brain used to feel that, you know, something is there, but in collection, I'm not feeling something is there, sir. Are you catching my point? His brain is not getting any fear and is not feeling that something is there missing. That's why he's feeling the depth and I'm not teaching. Because I'm revealed everything to you. The data structures is nothing but it is a bag. One bag I am giving to you. I taught you how to stitch that bag already. Now what you are doing, you are placing your things inside the bag and taking from that bag. That is data structures. That is called what? Collection. In your academics, you are not strong in programming. That's why you are feeling data structure is what? Very tough. Algorithm, flow chart. Okay, this type of big words they're adding and making data structures what? Very tough. Data structure is very simple. Loops, conditions, store, retrieve, update, delete. Simple. Data structure is very simple. Collections chapter is a data structure. In your academics, you felt multi-threading is the most toughest topic in your life. And data structures, nothing but collection is the most toughest topic in your life. But once I started multi-threading and data structures collections, you felt, what is there? Nothing. Actually, you will feel that object-oriented programming is the most toughest concept. In your academics, you felt object-oriented program easy, just to class, encapsulation, inheritance, polymorphism, abstraction. But we have spent a lot of time on this topic and we make you comfortable writing program. Then data structures and multi-threading become damn easy. So if you have full visualization on the concept, everything is easy. Memory diagram, if you visualize, everything is easy. Collections, when I'm teaching, multi-threading I'm teaching, first I will teach you diagrams. What you want? This diagram I want, then write the code. This diagram I want, then write the code. I want this operation, write the code. But in academics, what they're teaching? Writing code first. And they're saying that this diagram will come. Code to diagram will never come. Diagram to code. First, architecture is important. For example, you want to manufacture one bike. Then first bike diagram should draw on a paper. Then that diagram should implement in the factory. You want to construct this house on the paper. First, you have to draw diagram of the building, and then you should start go and construct. Same thing in Java I am following. That's why from the day beginning I'm telling Java is a memory based programming language. If you strong in memory, program will come automatically. If you strong in what operation you want to do, program will come automatically. Don't think in a program, try to think in diagram and formula. Yes or no? So slowly change your mind. Architecture is nothing but simple. Don't stress that word architecture. Architecture and a collection of boxes connected by forward arrow marks, backward arrow marks, down arrow marks, upward arrow marks. Ante. That is called architecture. JVM architecture and what? Bola. Architecture means what? Boxes here. JVM architecture also? Boxes. Boxes with forward arrow marks, backward arrow marks, top to bottom arrow marks. Tell me, your house is having architecture. Your house architecture also contains what? Boxes only. Outer box, 4 walls box. Inside what? Bedroom box, master bedroom box, child bedroom box, guest bedroom box, and next following by hall box, kitchen box, right? What do you call outside balcony? Yeah, what do you call balcony box? So, and on the top of the boxes, they have names. What is this? What is this? What is names? That is called what? House architecture. Same way, JVM is also having one architecture. Some boxes are there. The 4 walls is nothing but JVM dabba. Assume one rectangle box. Are you ready? Ready to talk now? Right? If you visualize and if you talk, JVM architecture will be completed. If you are not visualizing what I am telling and if you are not replying, then JVM architecture will make you, subject very tough. People who following me from now onwards by replying, subject will become easy, sir. Try to talk along with me. Tell me, when you run Java example, JVM is prepared by occupying some memory from RAM. Okay, next step is what? JVM requesting class loader to search for the example.class file in the hard disk and find what? Read the byte code and store inside JVM memory. Okay, wonderful. Go back to previous chapters. Inside a class, how many different types of members we can create? Inside a class, how many different types of members we can create? What are the different types of members we can create inside a class? Yeah. How much time you will think about? Inside a class, what are the different types of members we can create? Many types. 100, 200, 300, useless fellow. How many types of variables are there? 2 types, class level and method level. Currently, I'm talking about class level, method level, or class level, class level. Inside class level, how many types of variables? 2 types. What are the 2 types? Static variables, non-static variables. Now, how many types of methods? 2 types. Static method, non-static method. That means inside a class, how many types of members we can create? 2 types. What are the 2 types? Static members, non-static members. Okay, na? Under static member, static variable, static method. Under non-static category, non-static variable, non-static method. So tell me, inside a class, what are the different types of members we can create? 2 types of members, static members, non-static members. Clear? If you want to launch JVM architecture, okay, first of all, you should have a clarity on this. Why? JVM required to store your class bytecode and execute your class bytecode. Further, you should have understanding, first of all, this story. How many static members? How many different types of static members we have? Come on. Okay, first you tell me, what the purpose of static members? Static members are used for providing memory and execute logic specific to one object or common to all objects. Okay, repeat once again. Now onwards, until you talk, until you reply, I don't continue next statements. Understand? Because if you speak, then only you'll get a feeling you understood. If you're not speaking, I will not continue. Okay, I will not follow each and every person. Okay, I'll not follow. So you have to take initiation, come forward and talk. You will understand, because I need to complete syllabus. If you're running behind every student, syllabus cannot complete. Other people will get frustration. Okay. So people who are interested to learn, try to speak. If you all people are not interested, I will leave the class. You want me to leave? So punishment compulsory will come. But the punishment, I cannot beat, because Naresh sir not given me that permission. That's why I will punish myself. What is that? Leave the class. If I leave the class, today topic I will not cover tomorrow. Hello, today topic is gone. Then tomorrow topic, according to schedule, tomorrow topic I'll teach. Without today topic, tomorrow topic you cannot understand. Tomorrow also you will not talk. Then I will leave. Okay, na? Within 3-4 days, every day I'm leaving. Then you feel that anyways he's not teaching, why I should come? He will not come. Amaya, happily I will also not come. I'll start new batch. Another new students, new money will come. Okay, na? Ready, na? Come on, tell me. How many different types of members were there in the class? 2 types. What are the 2 types? Static members, non-static members. Okay. Static members meant for what? If you understand how many static members, list will come automatically. What is the purpose of static members? Static members meant for providing memory and develop the logic common to not develop logic, execute logic. Development is always common, only execution. Provide memory, execute logic common to all objects. Okay. Now, to provide memory, I need one static member. Once you provide memory, inside this memory, I should store value. Na? To store value means initialization. For initialization, static variable, I need one member. Okay. Next, after initializing, I should read those values and perform some operations. To perform those operations, I need one more member. Tell me, how many static members we have? 3. Number 1, static variable. Number 2, initialization, methods chapter. In methods chapter, I told initialization purpose, what is the block available? Static block. Then next, static method. If you want to start the class execution, I require main method. Na? Main method is also comes under what group? Static members. Then main method. Listen, whenever you create an object, every object contains inner type objects also. I hope already explained. If you take you as an object, your inner object is what? Heart. If you take a computer, computer inner object is what? Hard disk. If you take projector, projector inner object is what? Light. If you take fan, fan inner object is what? Condenser and winding, next word bearing. All these are what? Inner objects. So if you want to create inner object of an outer object common to all objects of outer class, then we require what? Static inner class. So totally how many static members are there? 5. Number 1, static variable, static variable, static block, static method, main method, static inner class. Tell me, opposite, static, non-static, opposite. Tell me, how many non-static members? 5. What the purpose of non-static members? Non-static members are meant for providing separate copy in every object and execute logic with the value. Execute logic separately with the values available in particular object. That means how many non-static members? Providing memory, non-static, below variable. Next, for initializing, non-static block. For developing operation, static method. Non-static method, non-static variable, non-static block, non-static method. Non-static main method. Non-static main method. Constructor. Okay, what this concept? Constructor, not non-static main method. Constructor. Static inner class, non-static inner class. Understood? So totally how many static non-static members we have? 5. Totally 10 we have. Okay. So when should we use static members and when should we use non-static members? Okay, I already concluded. What is that? When we want to store value and execute logic common to all objects, we must use static members. Next, when should we use non-static members? When we want to store value and execute logic specific to one object, then we should use non-static members. Up to now sleeping? Really? All points came to your brain? Okay. Until you are deep sleeping. When you are in deep sleeping, no disturbance will not come. No? Now the question. If I create a class with all these 10 members, and if I ask JVM to execute this class, how many members JVM automatically execute? Come on. When I start our batch, first day demo class, I asked you to talk or I started first? I started, then slowly I make you talk, right? And when you ask JVM to execute, JVM should start first. Along with the JVM, we will also involve. Listen, look at there. Totally 10 members are there. I have created a class. Inside the class, 10 members are there. Asking JVM to execute this class with these 10 members. Will JVM execute all 10 members automatically by its own? No. JVM executes by default only. Come on, bhaiya, answer. Static members are. All static members it executes? No. It executes only. Correct. Come on. Executes only main method. Come here. Static variables memory allocated, I told you. Without static variables memory, how main method can execute? Inside main method, you would use static variable, no? Can I access static variable directly by its name inside main method? Yes. Then tell me static variable memory should be allocated first, na? After memory allocated, it should be initialized, right? After initialization only we can access variables. Then who will initialize static variable? Static block. Then main method has a chance to execute. So tell me, all the people answer. What are the members automatically executed by JVM? Number one, static variable, static block, then main method. Then main method. JVM executes only these three members. JVM will not execute remaining members by its own. Are you following? JVM will not execute remaining members by its own because simple reason. How many memory copies should be provided for static variable? One. How many times static block should execute? One time. How many times main method should execute? One time. One time execution members JVM will execute. A member that has a chance to execute only one time in its lifetime, that member is executed. That member is automatically executed by JVM. Everyone following? A member that has a chance to execute more than once, then those members will not touch by JVM. Why? How many times to execute? How JVM knows? That is a developer responsibility to inform to JVM. This member execute these many times. Tell me, static method meant for executing business operations, with some inputs, right? Then now it generates some result, right? Tell me how many times this operation should execute, with what inputs this operation should execute, and the generated result, how to use, how JVM knows? JVM don't know. So that's why JVM is not touching static method, not touching static inner class. Next, how many times non-static members should execute? As many new objects as you create. So how many new objects you require? How JVM knows? Already catching my point? So JVM among all these 10 members, JVM executes only static variable, static block, main method automatically. JVM executes static method only when we invoke it. Okay, JVM execute non-static members only when we create object. All people understand? So hence, what is the recommended structure of the class? How to create a class? Listen, we will create a class with all these 10 static, non-static members in such a way. First, we will create inside a class what? Static variables, because one copy memory. Then non-static variables, individual copy to every object. Then initialization, static block, initialization, non-static block, and constructor. After initialization, then perform operation on static variable, static method, non-static variable, non-static method. And further we'll write a common method like display method to display both static and non-static variables. And at last, we may create static inner class, non-static inner classes if required. So this is the class structure. Where is main method? Come on. Main method is missing, na? Will you write main method in the same business class? No, we will create separately. But I want to execute this class by its own alone. If you want to execute a class by its own, what we require? Main method also. You can write main method anywhere your wish. Okay, right? I have written main method also inside bank account class after static, non-static methods. Then tell me, if I run the class Java bank account, what is the flow of execution? First, JVM is created as a process by taking some memory from RAM. Then it instructed the class loader to load the class bank account. Then class loader class loader finding the bank account.class file, reading the bytecode and load that bytecode inside JVM. Then JVM started run. Bytecode verifier verify. Interpreter came into picture. Interpreter started running it. Interpreter execute the entire class, all members by its own? No. First, it is allocate memory to static variables. Next, it executes static block. Next, is start executing with main method. Hello. Remaining all members. Okay. Bahubali, multiple arrows. 3 arrows. No? Right. Then now all these remaining members are executed only when we call. If you don't call, it will not execute. Sleeping? Then what's the step number? Step number 1, Java bank account. Then bank account class is loaded. Then static variable memory allocated, then initialize, execution started. Then remaining all members are executed only when we call. As many times as we call, those many times execute. All people understood? Yes, really? Mama? What? How can I understand here? Play once, sir. Why? We're not watching. What is still? Oh, music you want to play, na? Not this one, na? Okay, okay. You are hearing this one sound also there? Oh, wonderful, powerful ears you have here. Okay. Shall I go next slide? Now you got clarity on what are the different members available in the class. Then now I want to start designing JVM architecture. Ready? Tell me, architecture means what I told you? Multiple boxes connected with arrow marks. Okay, listen carefully. When you run Java Java bank account or Java example, JVM is first prepared. Visualize rectangle box, a big rectangle box. This rectangle box is nothing but memory, occupy memory from where? RAM. Okay. Now, in this memory, this entire class bytecode must be stored, na? Right? After storing, JVM should allocate memory for static variables. Right? After allocating memory to the static variables, JVM should execute static block logic and what? Main method logic. Right? Then after while static block execution or main method execution, I may call what? Static method. Then static method logic should execute. While static method logic execution, static method may have parameters, may have local variables, and then parameters memory should allocate, local variables memory should allocate, and method logic should also execute. Okay. The next, inside main method, I may also create object for bank account class or example class. Then tell me where object will be created. Object must be created. Inside object, non-static variables memory should be allocated, and those non-static variables initialization purpose, non-static block logic should execute, constructor logic should execute. Later, by using this object, I call non-static method logic also will be executed. Hello, all people understand? Then my question is, try to think how JVM can perform all these operations. To perform all these operations, JVM memory should be divided, na? JVM memory should be partitioned, equal memory, right? Equal memory partitioned location should be created. Now try to think now. JVM, that big memory is now divided into partitioned memory areas. JVM memory is divided into partitioned memory areas. Okay. How many partitioned memory areas? And the JVM, that big dabba, is now further divided into small dabbas. So how many dabbas are coming? Now I wanted to find out. For example, you take this classroom. This classroom is divided into two sections, boys section and girls section. And again in boys section and girls section, one dabba, small dabbas for each student. Okay, na? Same story now. Listen carefully and visualize. First step, what should happen in JVM? Read the bytecode and store. Immediately after storing bytecode, static variables memory should be provided. Hello? Again repeating, load the bytecode and allocate memory for static variables. Okay, these two activities must be performed. Next, objects should create, non-static variables memory should be allocated. Where? In the same place or another place? Another place, because many objects are coming different activity. Next, static block, non-static block, constructor, static method, non-static method. Logic should execute. While logic execution, parameter and local variables memory should be allocated. Where I should happen? First place or second place or another place? Another place. And the minimum how many memory areas will be there inside JVM? 3. Okay, in first memory area, class bytecode is stored, static variables memory allocated. Second memory area, objects created, non-static variables memory allocated. Third memory area, methods logic is loaded, parameters, local variables and logic will be executed. Okay, na? Listen, I want to give you one small story. Listen carefully. You know, I have defined main method. Inside main method, I call M1 method. Control is coming to M1 method. Inside M1 method, I call M2 method. Control is coming to M2 method. Inside M2 method, I call M3 method. Control is coming to M3 method. After M3 method execution completed, JVM shutdown. No, methods calling order. Do you remember? When I call method, control will go to called method. After called method execution completed, control return to calling method, and the statements placed after that calling method statement will be executed. My question is, after M3 method execution completed, control come back to where? M2 method. M2 method is calling method. And now tell me, M2 method execution is restarted or resumed? Resumed means from the M2 method calling line down statements are executed or not? How JVM knows that M3 method called from M2 method line number 4? From line number 5 onwards, I should resume execution. How JVM knows that? Next, after M2 method completed, how JVM knows that it should go to M1 method? And then at a sixth line, we call M1 method line. Down lines I have to execute in M1 method. After M1 method completed, I should go to main method, line number 1. After line number 1, line number 2 onwards, I should execute. How JVM knows? Somewhere it should store each instruction execution point. Na? How do you know after class completed, you are going outside to your room safely? Na? How? Because your brain remember the path and the address of your room. Yes or no? Like how you remember, JVM also should remember each instruction. So JVM is having one more memory area to store each instruction address to track the execution flow. Repeat once again. JVM have one more memory area to store each instruction address to track the execution flow. So totally how many memory areas are there in JVM? 4. First one is what? First one purpose is what? Byte code storing and then static variables memory allocation. Second memory area for objects allocation and non-static variables memory. Third memory space. So third memory area, methods, I mean, you simply can say logic execution and parameters, local variables, memory allocation, right? The next, fourth memory area for storing each instruction address to track the flow of execution. Up to now, okay, na? Java supports pointers. Come on. Does Java support pointer? No, Java doesn't support pointers. But I required pointers in my Java language to talk to computer hardware devices. Sometimes I want to work with pointers. Tell me, pointers concept available in which language? C language. Then develop pointers program in C and call the C program from Java. Possible or not possible? Come on, say yes or no. Why you are thinking too much? Possible or not possible? Possible. Tell me, if you go back to the JVM architecture, that 5 stages, interpreter convert the byte code to machine language with the help of underlying operating system. It is executing machine language, na? Operating system developed in which language? C. Java program interpreter is accessing the C program. No, and in Java I cannot develop pointers, but I can develop pointers in C program, and the C program can access from Java. Yes. A program, I mean, you are accessing a other program method only, na? So you can create one method in Java that is connected to C method. Already catching my point. JVM software developed in which language? Come on, yaar. C. JVM is a platform dependent, means it is specific to one OS. So JVM not developed in Java. Compiler developed in Java. Okay, JVM developed in C language. Now try to answer. JVM developed in C language. Then C program, can I say native to JVM? You are a Hindi person, Babu. Hindi word is a native to you. I am Telugu person. Telugu word is native to me. I develop C program, which is a native to JVM. Now I am developing one method. This method should work with what? JVM software. It should link to Java logic or C logic? C logic. Then this method which is working with C should call a Java method or native method? Native method. A method that has only declaration in Java program and its implementation logic is connected to C program, then that method is called what? Native method. I will ask one question. Try to answer. I want to create one method to call and execute without using object, then it should have one modifier. What the modifier? I want to create a method. I want to call and execute this method without object. Then what modifier I must use? Static. Do you remember modifiers? Reply. Modifiers are used for changing the default behavior of the programming element. What is the default behavior of a method? Call and execute by using object. I want to change its behavior without object. Then it should be what? Static. Listen. Now I wanted to create a method to tell to compiler and JVM. Its logic is not available in this class. Its logic is available in a subclass. What modifier I must use? I will only declare method here and its implementation there in the subclass. What modifier I must use? Protected. OMO. What? Abstract. That's why I asked a question today. Did you remember all points what I explained? All you say, yes, sir. But once I started a question, sir, no, sir. Smile. You know, whenever answer coming, no, automatically what will come? Smile will come, right? Come on, Rav, revise, please, Rav. Variables chapter, methods chapter, once again, please revise. Every Sunday, every day, just you revise. I'm coming every day half an hour late. That's why we are also coming half an hour late, sir. Kada? You know, students are, always better than faculty, plus. Faculty coming half an hour late, student will come 40 minutes late. Why? Yada Raja, Tada Praja. Right? 10 minutes minimum late will come after faculty. Faculty should wait for student. Student not waiting for faculty. Now, please come to the class by 9 to 9:30. Try to do revision of variable chapter again, method chapter again. These two chapters only you are going to write code every day in your life. Come again. I want to create a method to call without object. Which modifier I must use? Static. I want to declare method, means I want to ignore method body to write to provide in the subclass. Which modifier? Abstract. Listen carefully and answer. Why I revised? Because I want to connect it to new point. I have a bad habit. Whenever I want to introduce a new concept, first I will bring to old topic. Known topic I will take. Similar old topic I will take, expecting you to understand yourself and reply. Ready now? You want to create Java method with Java logic, with native logic? I want to create a method. Up to now, we created a method with Java logic. But I don't want to write logic in Java. I want to declare method in Java and I want to provide its logic in native code and I want to link that native code to my Java code. I should tell to compiler, na? If you only declare the method, compiler surprise and ask you why you declare only method when it doesn't have a logic. What the use of it? I should tell, or a compiler, this logic is available, this method logic available in subclass. How I informed? By using abstract. Now I want to tell to compiler, this method only I declare, its logic is available in native code in C++ program. I connected already, you don't worry. How can I tell to compiler? I should use a modifier keyword because default operation I changed. By default, every method should have body. Now I'm removing body and I'm placing inside native code. Then what modifier I should add before return type? Come on, guess. Static, abstract, native. I must add what keyword? Native. Come on, create one add method to develop in C language, public. What is the return type? What is the modifier there? Native. Return type, your wish. If you want only display result, void. If you want a return value, int. Assume that displaying, okay? Void. Method name is what? Add. Bracket, int a comma, int b. Open bracket, closed bracket, semicolon. Come on. Semicolon. Why? Body you are writing in this code? No. You are writing code inside C program. So if you want to create a method in Java, then don't use the keyword native, add body, write the logic. Sometimes I required some features which are available in another languages. If you want to connect your method to another language, C++ language, then you should create your method as native method. Native method means only you have to create declaration. Ends with a semicolon. Later, you have to create C program and connect that C program to this Java method. Sir, how can I connect, sir? By using one special API called JNI. What is the API? JNI, Java Native Interface. Okay, this concept is called what? Native method creation and connecting. Okay, I will explain that later. Okay, when time comes, I'll explain. Just you remember this much is sufficient. So tell me now, in Java, how many types of methods we have? 2 types of methods. Number 1, Java methods. Number 2, native methods. Tell me, buddy, Java methods are executed with logic available in Java world. And which is available in our method area, na? Sorry, which is available in first area, na? In first area already bytecode is loaded. Along with the bytecode class, the method logic is also came. So from the first dabba, now the logic is coming and executing in a third dabba. Dabba and a box, okay? Now my question, if the method is developed in a native language, is that native method logic available in JVM? No, it is available in hard disk. Now, this native method, whenever I call, this native method declaration should link with the native API, native library available in hard disk. Who will do this linking? JNI. Where? For that, one more dabba is there. One more method area, one more memory area is there. So there are two memory areas are there to execute logic. First memory area for executing logic with Java logic to execute. Last memory area is meant for executing native logic. So Java methods are executed in third memory area. Native methods are executed in fifth memory area. So totally inside JVM, how many operations I need to perform? 5 operations. Number 1, load the class. Load the class, allocate memory to static variable. That memory area is called method area. What do we call? Method area. Next, now create objects and allocate memory to non-static variables. That memory area is called heap area. That memory is called heap area. And next, logic load and allocate memory to parameters and local variables and execute logic. That memory is called Java methods. What methods? Java methods stack area. Methods are executed in which memory structure? Stack. Okay, stack memory structure. Main method first call. From the main we call M1 method. From M1 I call M2 method. M2 call M3. Last in first complete, right? So last called method first completed. That's why that structure is called what? Stack. Okay, Java methods stack area, because methods which contain logic in Java executing there. Next, next memory area is what it is doing? Storing instruction address to track the execution flow. That is called what? Program counter register area. What we call? Program counter register area. First memory area, please. Method area. Next one, heap area. Java stacks area. Program counter register area. Understand? Last memory area, Java methods are native methods. Native methods stack area. So repeat once again all 5 memory areas. Method area, heap area, Java stacks area, program counter register area. Last one is what? Native methods stack area. Okay, all these 5 runtime 5 memory areas are technically called runtime data areas. What do we call? Runtime data areas. Now try to answer now. When you run Java command, JVM is prepared by occupying some memory from RAM, and then the memory is divided into how many memory areas? 5 memory areas. Now JVM is ready. Babu, into these memory areas, class bytecode must be loaded by JVM or class loader? Class loader. On top of these 5 memory data areas, on top above, we will have what? Class loader. Hello, only class loader cannot work. Class loader has some assistance. Okay, some more helping programs are there. All these programs are called what? Subsystem. JVM is a one system. In that, some more group of programs are there. We call them as what? Subsystem. Group, subgroups here. Okay, so JVM is a one system, and a class loader, all programs together is called what? Subsystem. So what do you call a runtime data areas? Above we have class loader subsystem. It is responsible for what? Loading classes into JVM, unloading classes also from the JVM. Class loader subsystem is linking with runtime data areas with a loading arrow mark, unloading arrow mark. Up to now, understand? Then after bytecode loading into JVM, tell me this bytecode should execute. Who will execute? JVM executor, interpreter executor? Interpreter. Then down, always engine is available where? Down only, na? If you take a vehicle contains engine is responsible for running this vehicle. So where it is available? Down. Runtime data areas down, left side down, we have what? Interpreter. Only interpreter can execute? No. Interpreter. Next, JIT compiler. Then JIT compiler to help, we have hotspot profiler. Next, security manager. And also one more program is there called garbage collector. Once upon a time, long ago, you have learned. Garbage collector, one of the features of Java, right? So now these 5 programs are working together to execute the loaded program. All these are called together what? Execution engine. Hello, are you catching my point? Then execution engine is available down to the runtime data areas. It is connected to the runtime data areas to run the program, and for creating memory and execute, remove memory and also execute. So two-way arrow marks. Last corner we have what you call native method stack area. Native methods are loaded there, but its logic is available in JVM in hard disk. Now who will link that? JNI. So from the native method area, who is coming into picture? JNI. So tell me, JVM totally divided into how many components? 4. Number 1, class loader subsystem. Number 2, runtime data areas. Number 3, execution engine. Number 4, JNI. So these 4 components together, what is formed? JVM is formed. This one. Okay, so this is JVM architecture dabba, official dabba given by James Costley. Okay, hope all people are comfortable. So execution engine, whenever I say JVM architecture, this entire memory dabba should come into your brain. All people understand the narration? Right. So this is the theory, and tomorrow we are going to implement practicals on the JVM architecture with a program. All are comfortable? I'm going to dig into each runtime data area, that class loader subsystem dabba inside what is there, I'll show you. This execution engine inside dabba, what is there, I'll show you that. Okay. So we have more diagrams, elaborated diagram. This is outer look. This is complete inner look. Okay. So you want to become RMP doctor or MBBS doctor? RMP doctor know only outers. MBBS doctor knows inside also what is there, how the nervous system is there, how blood going, how blood coming, everything, you know. So we are going to discuss more. This is MBBS doctor. This is specialist doctor. Okay, na? Right? And finally with this diagram, we enter into programs. Okay, thank you. That's all for today class. Hope you enjoyed today class. Is my speed okay? All are you comfortable with my speed? Shall I change the gear? Now I am in 3rd gear now. Okay. After JVM architecture completed, I'll go to 4th gear. Okay. Come on with me. All points, whatever I have explained today, there in our material. Okay. Read material and come.